Alright, so for this practice problem here, this is an experimental design one, and we have a student testing out a Nerf gun they bought and wants to determine the launch velocity using only a measuring tape. Okay, so we're going to describe an experiment that would allow him to do it, and we're going to go through all the steps we normally do for an experimental design question. So the first thing I would think about is the fact that we probably want to fire this dart horizontally. Okay, that's going to make our life a little bit easier. So I'm going to say that initially we're just going to fire it horizontally, so we don't even have to deal with an angle. We only have a measuring tape anyway, so it probably would be difficult to solve for that angle as is. So we fire that dart horizontally, it falls some distance and hits the floor right here. So what I'm going to do before I go ahead and work through part 1 of A, I'm actually going to go ahead and think about what my setup would be. And so this is basically going to be part 2 of A here. So thinking about that flight through the air, I know my x acceleration is 0, my y is going to be negative 9.8 meters per second squared. I'm launching it horizontally, so my initial y velocity is 0, and this is what I ultimately want to find. Now let's think about things that we could get. We have a measuring tape, so we can measure how far it goes horizontally. We also can measure what the change in y is, that height. Okay, and that is going to give us enough information here on the y side to go ahead and solve for time and ultimately solve for that initial velocity in the x. So for the first part of A, we've drawn our diagram right here with the Nerf gun. We want to talk about what quantity we would measure and what equipment we would use. So we're going to measure the height of the dart, the initial height, and the distance traveled horizontally using our measuring tape. So that gives me my answer to part 1. Really, we're just worried about what we're measuring. For part 2, we're now going to go ahead and describe the overall procedure used. I do have my chart set up, but I'm going to start by actually talking about what I'm going to do to complete a trial. Once we fire it, we're then going to measure and record the height and the distance traveled horizontally. Okay, so that's going to be what we would do to conduct a single trial. And I am going to say that we're going to repeat this several times because it does say we want to talk about how we can reduce experimental uncertainty. Now in terms of actually solving for that velocity, that's where I'm going to use this setup and derive some equations that are going to be able to solve for that velocity based off of these two quantities that I measured. So starting with the y side, I know that my initial y is 0, so that first term goes away. I'm going to measure that height, which I'm just going to call h, and so whatever I measure, my delta y will be the negative of that, and that's going to be equal to 1/2 times negative 9.8 times t squared. If I go ahead and divide both sides by negative 4.9, which is 1/2 of 9.8, I get h over 4.9 equals t squared. So that means that my time is going to be the square root of h over 4.9. So the one thing I would write here is use the height to solve for time. Okay, that's going to be my first step in ultimately getting the velocity. And I have that equation here that I just derived where t is just the square root of h over 4.9. I'm now going to jump over to my x side where that second term goes away because my x acceleration is 0. And I'm going to say that my distance traveled, we'll just call that d, that's going to be equal to my initial velocity. Now that initial velocity in the x is the overall initial, so I'm just going to call it vi multiplied by my time. So my vi then is going to be d over my time. And so in terms of what we would do, we're going to use the horizontal distance and the time that we just calculated to solve for my initial velocity. And so there we have both a derivation and some explanation to go along with it for how we would ultimately solve for our initial velocity. So the last part here, we have a student's friend, Joe, who shows up with a Nerf gun that launches it twice as fast. And he claims that his dart will hit the ground faster because it fires it horizontally at a greater speed and therefore will cover that distance in less time. And we want to know whether or not he's correct and explain why. So at this point we should know that no, he is not correct in this situation. And what I would say the biggest point is that X and Y motions are independent of each other. And so even though his is traveling faster in the X direction, they both start with the same initial Y velocity from the same height with the same Y acceleration, so they'll hit the ground at the same time. The last point that I would add is that Joe's dart will travel further horizontally because of that greater velocity, but it won't change the time in the air.